This jet is built with extreme precision. Every part matters. Look at this. One wing alone takes thousands of careful steps. Every panel fits with micron-level accuracy. These tail structures control the jet's stability, gives the jet its iconic performance.
Welcome to the heart of our operations, where we utilize advanced automation to build the F-35 Lightning II fuselage.
Hold steady on the starboard side. Adjusting angle .02. Clear to engage.
Type 7 from something.
Variance on Sector 4 is stabilizing now.
Run final diagnostics.
Alignment confirmed and locked. Check the alignment on this strut here.
Reading confirmed, it's within tolerance.
Roger that. Torque is set.
The sensor array on the trailing edge appears misaligned. Cross-reference with the latest schematics.
Check the readings on junction 7.
The resistance is slightly high according to the schematic here.
The starboard alignment is showing a slight deviation near the intake valve.
Adjusting the trace parameters now. Rerunning the diagnostic sequence.
Check the tolerances on this section here. The reading seems off.
Yeah, the schematic confirms it. Let's log the deviation.
Okay, inspection point marked at section 4.
Recording discrepancy now.
Check the alignment on section 3. Looks nominal from here, uploading the data now. Check the tolerance on marker C14.
It's within spec, but the laser reading is fluctuating slightly. Check the alignment on the mid-body clamps.
Secure and within parameters. The scan confirms it.
Check the alignment on this starboard panel, station 452. The tolerance is tight, but it's within parameters. Gap measurement confirms it. Good to proceed.
Check the seam right here, near the panel.
Got it. Looks good from this angle. The coating is uniform.
The scan shows a slight variance on the port side panel here. Let me cross-reference that with a CAD model. The tolerance holds within acceptable parameters.
Data stream confirms secure connection.
Looks good from here. Finalize the sequence.
Look at the thermal overlay here. It's showing a consistent anomaly near the aft section.
Yeah, I see it. The pressure telemetry confirms the drop. Let's run the diagnostic again.
Check the starboard alignment on zone 4.
Looks good. Confirmed. Engaging robotics.
The stability reading on the port side is fluctuating slightly. See here. I see it. Let me try reseating this connection. I'm seeing a slight irregularity on panel 4.
Let me see that. The weave looks consistent to me.
The uniformity looks good here. All green on the gauge. Copy that. Data logged.
Alignment check complete on Station 4.
Acknowledged. Proceed with drilling sequence.
The structural integrity looks good, but the heat map shows a slight irregularity right here. I see it.
It aligns with the stress point near the actuator housing.
Alignment looks good. Lock it down. Torque is set. We are secure.
Check the alignment on station 4.
Looks good from here. All tolerances met.
The rotation is smooth, but I'm getting an anomaly at frame 7.
My scanner shows a minor surface deviation there as well.
Check the alignment on sector 4. The marker looks slightly off.
Acknowledged. Adjusting trajectory now, compensating for the drift.
Okay, the starboard reading is stable at 0.124.
See, that's exactly within the parameters we discussed. We are clear here.
Marker is secure.
Reading alignment at 0.01. Acceptable tolerance.
Look at the strain gauge readings right here.
It's well within the acceptable limits for this phase of the test.
Check the tolerances on the starboard side actuator housing. We need to verify alignment before the next phase.
Already on it. The readings look good here.
Tension levels stabilizing on the main spar.
Reading confirmed. Alignment is perfect. Reading steady now. What do you have? Confirmed. Within tolerance.
Alignment looks good. Lock the sequence.
Confirmed. Fastening sequence initiated. All green.
Scan on section Gamma is complete.
Consistency is within tolerance. Move to section Delta. Sequence complete. Green status confirmed on the tablet.
Acknowledged. Moving to the next mount point.
The pressure differential on the bypass is spiking right here.
Yeah, I see it. Cross-reference that with the temperature gauge near the nozzle.
Torque is set on the upper sensor. Reading confirmed on the diagnostic. We are good to proceed.
Engine 1 ready for power cycle.
Copy that. Cycling auxiliary now.
Look at that reflectivity. The tolerance is remarkable.
Indeed. The robotics are performing flawlessly on this section.
The reading is confirmed. Tolerance is within spec.
Verified. Make a note of that in the log. We can move to the next section.
This reading here, it's inconsistent with the material specs.
I agree. Let's cross-reference the sensor data logs immediately.
Check the alignment on sector 7.
Looks nominal. Calibration confirmed.
I'm seeing some wear on the forward mount bolt at the 3rd position.
Can you get a clearer angle on that? The resolution is a bit grainy.
Check the alignment on the starboard coupling. It seems slightly off spec.
The magnetic stabilizers are compensating. We're still within tolerance for this phase.
Okay, the sensor array is connected to port 3.
Confirming connection. I'm starting the diagnostic sequence now.
The turbine inlet temperature is spiking at throttle setting.
I see that. Cross-reference with the fuel flow metrics.
The laser scan on the turbine blade is reading 0.002 off nominal.
That's within the acceptable tolerance for this section. Mark it green.
Internal ducting looks clean, but log the hairline fracture near the seam weld.
Fracture at the seam weld. Noted.
We have confirmation on the stabilization matrix.
Final alignment is complete. Proceed with securing the clamps.
Check the emissivity readings right here at the seam.
The sensor array shows a slight deviation in the substrate bond, but it's within tolerance.
We're seeing a slight variance on the outer ring measurement. Okay, cross-reference that with the maintenance manual on the tablet. See that thermal fluctuation near the nozzle mount.
Yes, the signature is inconsistent with the baseline. The structural integrity seems stable, however.
Bracket secured to spec. Confirmed.
Data stream shows green across all parameters.
Acknowledged. Notifying control, we are approaching the transfer point. The scan confirms the tolerance is within spec at this point.
Confirmed. The caliper reading matches the digital overlay.
The clamps are stabilizing now. Check the readout on sector gamma.
Green light on the adjustment. We are within tolerance.
Check the trailing edge data right here.
Yeah, I see the anomaly. Let's rescan that quadrant.
The schematic calls for 3 millimeters at this intake point.
I'm showing 3.1 on the sensor.
We are clear for install.
Sensor 7 alpha alignment looks good. Are we green on the diagnostic?
Confirmed. All parameters are nominal. Proceed.
Check the sequencing on the auxiliary power unit.
Confirmed. All parameters are nominal.
Torque check on station 4.
Reading nominal. Good to go. Good to go.
Look at the stress reading on station 4. It's spiking again.
I see it. Rerunning the diagnostic sequence now.
Securing the final latch now. See the green indicator?
Confirmed. Let's run diagnostics on the port.
This guidance system checks out. Serial number matches the manifest. Good. The last batch had 2 discrepancies on the stabilizers.
Looks good. Go ahead and secure the bracket.
All right, applying torque now.
Joint 42 alpha checked. Torque looks good. Green on the tablet.
Check the alignment readings on screen B.
Yeah. Looks stable. We are good for the next step.
The lateral alignment on the port side is off by 2 millimeters.
Rerunning the scan. Okay, it's within tolerance now. Good to go. Check the voltage on line 12. Reading nominal. Secure the harness. Check the synchronization on bus 3 right there. Yeah. Adjusting the gain now. Looks stable. Perfect. Check the continuity on harness 7.
Reading green across the board. Securing the final connector now.
Alignment complete. Run the diagnostics check.
Solid telemetry across the board. We have a green status.
Torque reading confirmed at 25 Newton meters.
Roger that. Checkpoint 4 complete. The calibration cycle is complete. We have a green status across the board.
Excellent. The alignment is well within tolerance.
Reading steady at 5 volts.
Confirmed. Confirmed. Moving to the next point.
The alignment looks good from here.
Data confirms the calibration is within tolerance.
Ensure the hydraulics are fully pressurized before we seal the panel.
Yes, Supervisor, we are running the final check now.
Manifest confirms part 402. Verified. Looks clean.
Take a look at this connection point. The scope shows a slight irregularity.
Pulling up the data now. It seems consistent with the latest revision.
That's the last one. 4 Popeye 9.
Roger that. The value is logged. Sequence complete.
Calibration sequence initiated. Power levels holding steady.
And we have a green status across the board. Final diagnostics complete.
Easy now, watch the starboard side. Clear on my end, supervisor. Lock it down.
Clear to connect the tow bar, over.
Roger that, connecting now.
Power systems check is green.
Primary actuators are showing green across the board.
Looks solid. The alignment is confirmed.
This reading here on the auxiliary power system seems low.
Let me see. No, that falls within the acceptable margin after the last update. The pressure reading on the left gear is still fluctuating outside the acceptable parameters. Are the hydraulic pressure levels stable?
Confirmed. All systems nominal.
All right, surface check complete. The stealth coating is perfect.
Good copy. Finishing the canopy seal inspection now.
That's a wrap, gentlemen. Final assembly completed!
We did good work here, my friend.
The precision is unmatched. Incredible craftsmanship.
Hold short at the line, brake pressure steady. We are clear on the left. Clear left side.
Copy that, right side clear. Proceed slowly now.
Inspection point 4-7 is clear.
Roger that. Recording final approval.
See, the thermal readings are stable now. The adjustment worked.
Good. Let's run the full systems diagnostic before finalization.
Look at her. Absolutely flawless, ready for the skies. The best one we've built yet.
The bird looks ready. All parameters nominal.
Just need your signature on section 3, Captain.
Good work, gentlemen. She's fully mission capable.
The Lightning II represents the pinnacle of aviation, built by the dedicated hands of those who stand behind it.